Greetings, fellow mathematicians. We're going to take a look at a really simple but important question. What is substitution? The answer is really simple. It is the chain rule reversed. Now let's first see why that is, and we need two things. First, let's restate the chain rule from your Calculus 1 course, where we have the derivative of a composite function, f of g of x. We refer to g of x as the inner function, and this is the statement of the chain rule. We differentiate the outer function, plug the inner function back in, and then multiply by the derivative of the inner function. Basic chain rule that you all know. Now the second idea occurs later in your Calc 1 course when you were introduced to antiderivatives. You can have this statement written in the language of derivatives, capital F prime equals f, or you can switch that into the language now of integrals or antiderivatives. The integral or indefinite integral of f of x equals capital F of x. So we have the same two statements just written in a different language. Top version is differential calculus, bottom version is integral calculus. Now how do we combine that with the chain rule here? Well, basically what this says is instead of having a derivative here, you can have an integral here, and they should cancel out. So think of this as integrating both sides. Integrating a derivative should cancel, and we'll be left with the integral of little f of x on that side. So here, we can just flip this around. If we integrate this, we should get the function that we were differentiating. So let's go ahead and write that. If I integrate f prime of g of x times g prime of x, this is us reversing the chain rule. If we integrate this, we have to get f of g of x plus c. And that is substitution, except there is no substitution here. This is the foundation for substitution, but how we make use of it is we take something that looks really complicated, so think of this as a complicated integral, and what we want to try to do is convert it to a simpler one. So let's write that as the main idea. Of substitution. You're going to choose a substitution and then convert to a simpler integral. And ideally, your simpler integral is just a basic antiderivative. All right, now this is the chain rule reversed, but it doesn't tell you how to choose your substitution. So let's section that off. That's a great start to understanding substitution, but it's not typically how it's going to be used in practice. So let's suppose we have the integral of a composite function with a derivative on the outside. So let me rewrite this without the prime there. Let's rewrite this as some function f with g of x inside times g prime of x. All right, and this is where we're going to see how in practice we use substitution. Now think back to what the chain rule was about. The chain rule was all about inner functions. So how do you choose your substitution here? Choose your substitution, u, as an inner function. So let's say u is the new variable, which is standard, and we're going to choose u as the inner function here, what's inside f of x. We're going to choose that as g of x. All right, and how we convert here to get g prime, we're going to differentiate this and get the differential of u, what's called du. And that simply is just taking g of x and differentiating it and multiplying by dx. And what this substitution allows us to do is take something that looks complicated and convert it to a much simpler looking integral. And let's go ahead and do that. Notice here f of g of x is being replaced with u. So I can replace that inside with u, and g prime of x dx, that's just going to convert to du. And if you write down your conversion, your simpler looking integral, we have f of u times du. And that certainly looks much simpler than what we started with. At this point, you'll know if your substitution was correct because here, you almost always want that to be a basic antiderivative. And typically, the problems in your Calculus 2 course, they might look awful or brutal, but with a correct substitution, you can get something that looks really simple as long as it's a basic antiderivative. And there we go. So here, when we choose our substitution, we almost always try it as an inner function. And that is one of the ways you choose your substitution. The other idea to make the conversion work is you need a factor of your derivative. In other words, if you choose u as g of x, you need a factor of g prime. So a second tip is we would say choose u so that its derivative, here that's g prime of x, is a factor. Specifically a factor inside the integral. And that should guide you through most of your choices for substitution problems in a standard Calculus 2 course. Now there's also the issue here, what if we have a definite integral? In other words, let's say we had limits a and b on our integral. So let's say the integral here was the integral from a to b of f of g of x times g prime. All right, we can still use our same substitution here. That doesn't change with a definite integral. We still try u as g of x. G prime dx is still du. But now we have one extra part to convert. We've converted the function. Here, we're converting the differential. I always advocate to convert the limits. Here, a and b are x limits. We're going to convert them to new u limits. And all we're going to do is make a simple conversion chart. All right, so we're going to start originally here with our x limits from a to b. And if we use a substitution, u equals g of x, all we do to determine our new u limits is we just plug in x is b and x is a. So if you do that here without a specific formula for g of x, we get here g of b, plug in x is a, and we get g of a. And everything converts the same way. We convert the function, we convert the differential, but now we're converting the limits. So what this would look like, pretty much the same as above here, we just have new limits, g of a to g of b. And we're still integrating f of u du. And that's how we use substitution with a definite integral. In my Calculus 2 course, I always advocate when you do a substitution with a definite integral, convert your limits here, and it allows you to never have to back substitute your substitution u in terms of x. All right, now just to emphasize, what we're doing here is converting three things. And this is great to keep in mind, especially for those of you moving on to multivariable calculus when you get to coordinate transformations. So first, we convert the function all right, that's converting f of g of x to f of u. We also need to convert the differential in various factors of dx to du. And the last part, what we saw here, is we converted the limits from x equals a to x equals b to new u limits. And again, we did that using our substitution here, just plugging in our values for x to our substitution, u equals g of x. And there we go. We have all the important information here, as well as indicating how we actually use substitution in practice. The main idea, try choosing u as an inner function. That almost always works. And also keep in mind, choose u so that its derivative is a factor. Hope you enjoyed the video. If you did, like and subscribe.